எல்லாருக்கும் இனிய மாலை வணக்கம். அழகானதொரு மாலை நேரம், கண்களோடு மனதையும் சேர்த்து மயக்கும் மாலை நேரம், செந்நிற கதிரவன் தன் வீடு திரும்பும் நேரம், நீலவானில் நிலா மகள் உலாவர தொடங்கும் நேரம், பறவைகளின் பறந்தோடும் ஓசையும் தென்றலின் இனிமையும் ஒரு சேர நம்மை ஈர்க்கும் இன்பமயமான இனிய நேரம். அப்படியொரு மாலை நேரத்தின் மாயாஜாலத்தை பல்வேறு வார்த்தைகளால் விளக்கி கூறினால் கூட இதையெல்லாம் கடந்து நம்மில் ஒரு புதிய மாற்றத்திற்கான, புதிய திருப்பத்திற்கான முதல் படி எடுத்து வைக்கும் ஒரு அற்புதமான மாலை நேரம் என்றுதான் இன்றைய நாளை நான் சொல்ல நினைக்கின்றேன். பல்வேறு கனவுகளை சுமந்து சாதிக்க வேண்டும் என்று உத்வேகம் உள்ளத்தில் ஊற்றெடுக்க, சிந்தனைகளுக்கு சிறகுகளை முளைக்கச் செய்து பட்டாம்பூச்சிகளாய் பறந்து தெரியும் அழகிய பருவம் பள்ளி பருவம். இந்த பட்டாம்பூச்சிகள் எல்லாம் கூட பறக்க முடியாமல் சிறகுகளை முறித்து கொண்டு கூட்டுக்குள் அடைய நேரிட்ட அந்த பேரிடர் காலம் நம் கண்களில் இருந்து வேண்டுமானால் மறைந்திருக்கலாம். ஆனால் நம் மனதில் அதன் தாக்கம் இன்னும் மாறாமல் தான் இருக்கின்றது. அப்படிப்பட்ட கொரோனா பெருந்தொற்று காலத்தில் இந்த பட்டாம்பூச்சிகளின் சிறகுகள் எல்லாம் முறிந்து அவர்கள் வீட்டுக்குள் அடைபட்டு கொண்டிருப்பதை பார்க்க முடியாமல், இந்த பட்டாம்பூச்சிகளின் கனவுகள் அப்படியே முடங்கிவிடக் கூடாது என்று சில நல்ல உள்ளங்கள் அவர்களை எப்படி ஒருங்கிணைப்பது என்று சிந்தித்ததின் விளைவுதான் இந்த ஏவுகலன் அறிவியல் கல்வி. யார் அந்த சில நல்ல உள்ளங்கள்? அப்படிப்பட்ட மாபெரும் ஆளுமைகள் யார்? அவர்களோடு தான் இன்று நாம் இணைந்திருக்கின்றோம். கொரோனா பெருந்தொற்று காலத்தில் கற்றலின் இடைவெளி, மாணவர்களின் சிறகுகள் முறிந்த காலம், இதையெல்லாம் மீட்டெடுக்க மிக பெரிய ஆளுமை சிந்தித்தார் பத்மஸ்ரீ பத்மபூஷன் டாக்டர்.A.சிவதானு பிள்ளை ஐயா அவர்கள். அவர்கள் வழி நடத்த, அவர்கள் வழியில் அகத்தியம் அறக்கட்டளை நிறுவனர் மதிப்பிற்குரிய டாக்டர் பாலமுருகன் மற்றும் உற்சாகோ சொல்யூஷன்ஸ் டாக்டர் டி கோகுல் சயின்டிஸ்ட் இஸ்ரோ.
ஆமா பாலா சார், நீங்க வெல்கம் அட்ரஸ் கொடுத்துருங்க. நெட்வொர்க் ஆயிடுச்சு போல மேடம்.
சுதா மேடம்.
Good evening to you all. I am B. Sudharani of Agathiar Trust. Feels immense pleasure in welcoming you all for yet another series of Agathiar Rocket Science program. I am very happy to welcome our godfather, Dr.A.Sivathanu Pillai sir, who is always a main pillar of our program. Next, I welcome our two supporting pillars, Dr. J. Balamurugan and Dr. Gokul, who is a scientist in ISRO. I also welcome Dr. Rajalakshmi ma'am, who always extend her helping hand in all our efforts. I also welcome Logamani ma'am for being a part of our team. Also, I extend my welcome to all the principals and the teachers of the schools who has encouraged their children to participate. And finally, I welcome all the children of India as well as abroad and the children who has joined from UAE for yet another interesting session of rocket science program. Thank you.
Gokul sir. Gokul, you can go with the session.
Google? Yes, sir. Okay. So very good evening to all present here. So it's an important day for us that we are all with our Dr. Pillai sir. So to say about the journey of our rocket science, it is not started today. It is almost started 3 years before. So when we initiated, almost again the 500 students from across Tamil Nadu, they have joined. And with the guidance of Dr. Padma Bhushan Padma Shri Pillai sir, they learned the rocket science. and now they are all in the good position in various colleges. But what they really achieved, rocket science is something like we think it is something a biggest level of subject where nobody cannot teach us. But the 40 years period where the close friend of Dr. Abdul Kalam is Pillai sir. And he worked in ISRO and he was there in DRDO and he's the father of BrahMos. With all his experience, now he's trying to share his knowledge for the young people of our country as well as for the Tamil Nadu. So the journey I've initiated in 2022, and from there, I think the journey has traveled for various level of inspiration. And at last, the journey ends with taking 50 students, top 50 students to Russia. Why Russia? Russia is the first country to initiate about space, and Russia is the first country to take man to the space orbit. And again, Russia is the first country to launch many rocket launch vehicles and explore the various missions which no other people in the done in the world. So that is the where like the 50 students, selected students from 500 students has taken to Russia, and they have explored the Yuri Gagarin Center. They have explored the Science City. They explored the Roscosmos, and that makes them proud. And now every student is studying in a very big college, initiated from College of Engineering, Coimbatore Institute of Technology, KSR, JPR, and many more. So with that note, it is again, I think we are have been started our version 2 with our guidance of our Pillai sir. So it is very humble that you're all going to get learn from Pillai sir itself is something like you're all blessed children. So definitely after the 10 sessions of Pillai sir, you will all become a rocket scientist. So with that note, thank you so much sir for joining. And also I extend my thanks to Agathiam and Ushago Solutions for making this effort along with Rajalakshmi madam. Thank you sir.
Thank you. Dr. Balmanan, give a background of how many students are from Tamil Nadu, how many students from outside Tamil Nadu, then from outside India. Some background, please give me.
Yes, sir.
How many
Yes, sir.
government, how many non-government?
Yes, sir. So here today, people have joined from different parts of the country as well as the other part of the world too, sir. So like in and around Tamil Nadu, we have more than 150 students, sir. So as of now, there are 150 students from, namely from Jawgar School, KSR School, Saint Anthony School last week, wherever we went. So they have joined, and we also have the school students from E-Road, other 15 districts, sir. So there are more than 15 districts they have joined, and we also have people from Gujarat and Maharashtra. So 2 to 3 people have joined from Gujarat and Maharashtra, and we also have 4 to 5 people from UAE, sir. So they have also joined today, and we also have people from other states. So they are they are from Tamil Nadu, but they are staying in other states, sir. So they have joined, and we also have students about to join, sir. So we have 2 to 3 people. We are making them to write the examination, and today they would be joining, sir. So by next class they would be joining.
So all of them have gone through your test, preliminary test?
Yes, sir. Yes, sir. The now whoever attending, they have gone through the test and they have also scored very good marks, sir. So those people who have scored very good marks have joined. They almost there were 230 people, sir. So right now, I think that they have some difficulty in joining. So today it might they might join by 200 as of now, sir. As of now, 170, maybe 200 they would reach, sir. Yes, sir.
So I can share the slides and start?
Yes, sir. Before that, I just wanted to read out your biodata, sir, with your permission.
No.
Yes, sir. Thank you so much, sir. So I take the
very short, because they would have seen in the net.
Yes, sir. So it is a long thing, but still I'll cut short it, sir. So thank you so much for the opportunity, sir. I take the privilege in reading out sir's biodata. So who has a vast experience, and he has a vast experience traveling with Abdul Kalam, so with 40 years of experience with Abdul Kalam. So Dr.A.Sivathanu Pillai, who is a founder, CEO, and MD of BrahMos Aerospace from 1995 to 2014, and he was also served as a professor in ISRO, distinguished professor from 2015 to 2018. And he was also a former chief controller R&D DRDO from 1996 to 2014. And he was a honorable professor working with the Indian Institute of Technology, Delhi from 2015 to 2016. And he was also a visiting professor in the Indian Institute of Science, Bangalore, 2014 to 2015. So he was also a former chairman of BOG, NIT, Kurukshetra, and the president of Project Management Associate India. So now he made a vision that he just want to connect to 1 lakh students. So the rocketry is something like which is unknown to many such people. So, but his vision to ensure that the students learn. So when there is an idiom, so like whenever people talk tough about something, they would use an idiom. Why do you talk like a rocket science man? So that's the idiom usually people use to talk. But Sir made it with a 15 days class that every students today after COVID, we could see that each and every school is working with rocketry and other satellite technologies. It's because of him that today all the schools have started rocket science club as well. So today we are about to have the second phase of this program, so which should enable all the students and teachers to have an opportunity to interact with the sir. So thank you so much for the opportunity to read out because it is a very lengthy biodata, so which would need more of time. So I don't want to miss out the opportunity. So like I would pass on the mic to sir so that the classes would be continuing, and in the coming days we can know about sir. So thank you so much, sir. Thank you.
This 159 includes the teachers also?
Yes, sir. So only one coordinator per school has been admitted, sir. So they have joined.
How many teachers are there?
Almost 23, I think so, sir. 23 teachers as of now, sir.
So 159 means the students plus the 23 teachers.
Yes, sir. Yes, sir.
No, sir, now 171 is there, sir.
Ah.
Almost 150 students are there and 21 teachers are there, sir.
Okay. Thank you very much. So good evening to all of you. So let me share my slides. So welcome to the young rocket scientists. So I am adjunct faculty in IIT Madras and also professor in IIT Bombay. And I am also a chair professor in SRM and president of Project Management. This is my current assignment. And I was earlier in the BrahMos and also in DRDO and ISRO. So that is my background. I worked with Dr. Abdul Kalam for 40 years, as Dr. Balmurugan told. So you must have heard about the war, India-Pakistan Operation Sindoor, where we made the Pakistanis to surrender by launching, by attacking with BrahMos missile. That's a product which I worked for. So now let me talk about universe. So we are now in the rocket science program. Not going. Are you able to see the slide fully?
Yes, sir. Yes, sir.
Hide. Okay, right. Now it has come. So we are going to study about rocket science. You know, you have got your laptop, you have got your notes, and you are going to build a rocket, and you want to go to moon. Yes, all these things are possible. Earlier, when you were young child, your mother fed you showing the moon, and you were astonished to see the sun, stars, and the moon away from you. So now it's all in our hand today. Have you ever thought that human will go to the moon? Yes. Today, Neil Armstrong and others have landed on the moon from July 1969 onwards. 12 Americans have landed on the moon. And, before all these things, there were people who were trying to fly. So they put a big wing like this, like a bird, started jumping, and most of them died. So then the president of the Science Society of the world, that is in London, the president of that, William Kelvin. This Kelvin is very famous for, we talk about degree Kelvin, no, that Kelvin. So he told that heavier than air flying machines are impossible. That means you people don't try and die. It is not possible to have an aeroplane. That he told in 1892. 1903, the Wright brothers, they proved that no, we can fly. So how they were...
On December 17th, 1903, the history of aviation was changed forever when the Wright brothers made the world's first successful flight. You might think that their design was so simple. The propellers move the aircraft forward, the wings produce the lift, and the aircraft stays in the air. But when you examine it closely, you will be amazed by the numerous ingenious technologies these high school dropouts developed 100 years ago. Their design was so complete that even the current modern aircraft use the same principles of flight. First things first, to make an aircraft fly, you have to first overcome the pull of gravity, or, in other words, you have to produce a lift force. The Wright brothers borrowed the idea of lift generation from their own earlier experience on gliders. They knew that when air flowed over a curved surface, it generated a lift force. The higher the speed, the more would be the lift force. An increase in angle of attack also increased the lift force.
So we'll see this later. But what I'm trying to tell you, that it is possible to make an aircraft. They proved that. At the same time, another person called Konstantin Tsiolkovsky, he is from Soviet Union. He said, what can be more fantastic than to land on the surface of the Mars? A new great era will begin in astronomy from the moment of using rocket devices. So he thought that there will be rocket devices and the human will go to the Mars, settle on Mars. That's what he said. So it is a great vision. So vision and the courage will take one to very great heights. But what is the minimum requirement for that? Is the innovation. You should think differently so that your vision can lead to some achievement. So there is no word impossible. So you see today, man landed on the moon, rover landed on the Mars. So many things are happening. This man's vision is getting into reality. Now all these things are possible. Now you see the Yuri Gagarin, the first man to go to space, Neil Armstrong to land on the moon, man to walk, Alexei walked in space, our Rakesh Sharma, first Indian to go to space. All these things are happening because we have got a man landing on the moon means you need something to take him to that place. That is called the rocket. You see a big rocket called Saturn, which was designed by Werner von Braun. He is a German and he made the rocket for America. So during the race of between the Soviet Union and the USA, the Soviet Union was taking a big lead in space program. So the Americans thought to overtake the Soviet Union, the Russians, we should have something different. So he thought we should put the man on the moon and bring him back. So then they thought we should design a big rocket. This is a rocket. You know what is the length of this rocket? It is 110 meters. You may be running 100 meters dash, It is more than that. This is the length of the rocket. And you know what is the weight of that? It is 2.8 million kilogram. that meant 2,800 tons weight, 2,800 tons. It generates a big thrust in 34.5 meganewtons thrust it generates. And what velocity it goes? The top velocity is 28,000 kilometers per hour. And very huge. The cost is very high. $1.5 billion per launch. So at that time. So it's a very big program they started, and they put the first man on the moon. You can see Neil Armstrong getting down to the moon and putting the flag. So moon is reachable. That's the main thing you should know. So how it is reachable?
T-minus 17, final guidance release. We'll expect engine ignition at 8.9 seconds. 10, 9, 8, 7, ignition sequence started. All engines are started. We have ignition, 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad. It has now cleared the tower.
Camelot, wide on target. I see it. We got them all. 42 degrees, 37 degrees, to 5,500.
Yes, about
38 degrees.
Algeria,
go for landing. 42 degrees, to 4,000. 47 now. Okay, I've got Jorge, I've got Poppy. Each dot is good. Degrees, Gene. Altitude and feet per second going down to. It feels good. 110 feet, stand by for some dust. 50 feet, going down at 3. The surface at Taurus Littrow.
He has landed.
We'd like to dedicate the first step of Apollo 17 to all those who made it possible.
So how they work on the moon?
Well, we'll check on that. I don't think it is, though. Well, it looks that the way that line crosses there. 1,000 on the command.
That same, Bob.
100 on the OMP, so we're... Is that 1,100
all these
on the
big
last?
clocks that I've looked at
Right, okay.
look like the Jabronic rock I was talking about. Possibly upwards of 50% plagioclase rather than 30 like the Mare.
See, the
Put an intermediate gabbro of some kind.
1/6 of the Earth.
And
So you can't walk
one
like
big
that.
block there had
So-
very sharply defined
Way to go.
American challenge of today.
So then,
Has forged man's destiny.
So we also have now reached the moon, but that to the south pole of near the south pole of the moon. That is our Chandrayaan-3 program. The details we'll discuss later. But what I am trying to tell you, that moon is reachable. Mars, our rovers have gone. Human being will go to the Mars also. So these are the possible things in the near future. So India has launched a big program called Human Space Program. And you know that this is Shukla talking from the International Space Station. So he has reached there. This is the space station where he has gone, which is 400 kilometers orbiting around the Earth. So he has seen the Earth from the station, he has seen the Earth, and he has happily come back. So what is this about? What are we talking? We are talking about rocket. So this is a rocket. This is our first rocket of India called SLV-3. It's going up, but the flame is that the exhaust is coming down. So let us understand the principle. You take a balloon, fill with air, then you blow it, the air full. Then you open this nozzle. So the air comes out like this, but the balloon goes this side. So this is called action reaction. So when the exhaust comes down, but the rocket goes up. This is the Newton's third law. Let me show that experiment, how it is, how you can make it. This is an experiment
science experiments.
So the experiment is tying thread
After you have that
between 2
secure,
points and then put
straws,
the
so I'm going to go ahead and cut the piece
see,
off right below the section where it bends. If your straw is one of the straight ones that doesn't have the bend, you won't have to cut it.
So this is a straw for our what you drink, cold drink, the straw. Then
So now
take
I
the
have
straw
a straight straw.
and then put it in the
The
thread.
next thing I'm going to do is I'm going to take 2 pieces of
The thread.
tape.
And
onto the outer edges of the straw. So there's one piece of tape, and I'm going to take another piece I'm going to put it on the straw like that. So now that I have my straw ready, I'm going to take the end of my string and I'm going to thread it through the straw.
you have to put through the straw inside. Okay. Tie it to the other side.
Like so. Then I'm going to take this end of the string and I'm going to tie it on. As you secure your string to the second object, you're going to want to make sure that the string itself is tight and there's no slack in it. Then you're going to take your balloon and you're going to blow it up.
Balloon.
So once you have the balloon blown up, you're going to hold onto the mouth of the balloon to not let the air escape. And you're going to position it underneath your straw and you're going to place the tape on the balloon. And I'll show you what that looks like. So you'll see how the tape is secured to the balloon. Then you're going to hold the balloon like this, and the next thing you do is let go. So do you know why this happens? Leave a comment below to submit your guess, and then visit CoolScienceExperimentsHeadquarters.com to find out the answer, as well as find many more that you can do at home too.
So what has happened is the exhaust comes
3, 2, 1, now, 1, 2.
So direction of the exhaust, direction of the rocket. So this is the Newton's third law. For every action, there is equal and opposite reaction. Okay, we'll study this in detail later. Now I am trying to show you who made the first rocket. This rocket.
The British encountered these new metal rockets for the first time at the Battle of Pillai in 17. The British brigade. Tipu's rocket set fire to a British ammunition cart, which contributed to the defeat and surrender of the British brigade.
So initially, the Chinese started making fire arrows. You know, this arrow, they put a bamboo opening, and then they put the gunpowder inside, fire that one, so the arrow goes at a faster speed. This is the initial finding, but we thought that instead of putting in the bamboo, we should put in a metal. So we have taken a iron, wrought iron casing, then put the gunpowder inside, 2 kilograms of gunpowder, and then attach a sword into that. There is a nozzle and then ignition system. This is the principle of rocket we followed first time in Mysore, Srirangapatna. More than 6,000 rockets were launched against the British, who came in the cavalries. Cavalry means horses. They came to run over Tipu's men, but they were defeated because they were having guns which can go, the big guns they were having, and they can go only 200 meters. Whereas these rockets go more than 1 kilometer. So easily the British were defeated. You can see that type of rocket which they are keeping in their arsenal in the Woolwich Artillery Museum, London. This our rocket is kept there with a video which you have seen saying that the British were defeated using this rocket. This is the first rocket that they have acknowledged. So this is the original development of the rocketry, and the credit goes to the Mysore Kingdom who has started the rocket. See that you can listen now to the final wordings, you can see that.
Tipu's rocket set fire to a British ammunition cart, which contributed to the defeat and surrender of the British brigade.
So British man is saying that defeat and surrender of the British. Okay, that was the rocket. Now later, we developed a big rocket. So Dr. Abdul Kalam is here, you can see Abdul Kalam. He was the project director for making the satellite launch vehicle. He launched. So that is how India entered into space program. India became a member of the space club by launching the SLV-3. And we were all his team, the core team people who are standing there. And the big people are Brahm Prakash here and Dhawan, Satish Dhawan, who was the chairman. All these people were involved. On 18th July 1980, SLV-3 was launched very successfully to put the Rohini satellite in the orbit, Earth orbit. So that is our space program. So today we have got many rockets. And what is a rocket? Rocket has got a chemical that is called fuel and oxidizer in the liquid. This is a liquid. Solid means it will be totally a solid. Here I am showing a liquid rocket. Fuel and oxidizer, they burn together through the combustion chamber. This is the combustion chamber, and through the engine, they come out. The exhaust comes out at the bottom, and the purpose is to go to space and put the satellite in the orbit. So rocket takes spacecraft to the orbit around the Earth, or to give velocity to escape from the Earth for space exploration. So what is rocket? Rocket is a flying vehicle that is propelled by a chemical explosion fired from the back of the airborne vehicle. Okay, who are the pioneers of the space research? Aristotle started talking about space first, but the real idea of the space in Western world came from this man, Ptolemy. He said that the sun is revolving around the Earth. That was his theory. So his theory was wrong. So the Copernicus, he said that no, sun is the center and all the planets are revolving around the sun. So Galileo came and he proved it. He proved it through his telescope. And also he has identified two new planets, the Neptune and Uranus. They were not seen earlier, but he found out that. And Kepler said, no, it is not. They are not revolving in a circular orbit. They are elliptical orbit. So like this, new theories came, and Newton came. Newton gave the theory of the gravity as well as the motion, theory of motion. Then Einstein came and he studied about the universe, and he gave not small theory. He talked about the big theory, which the theory of relativity. Gravity, there are two views. Newton said that gravity is a force, and Einstein said no, it is not a force. It is it's a distortion of space and time. Depends on the energy. So these are the views of the people. Of course, in India, many scholars came in the early days, much before these people, and they have talked about all these things in the earlier days. So we will see that in the later classes. Now the very important thing is this person, Przewalski. he gave the rocket equation. He says rocket can be there, rocket can go to Mars, put the man on the surface of the Mars. So that was his thesis. So he talked about the 1896, he said new rocket will come. Then practically rocket was made by Goddard. He's an American. He made a first rocket, he made it. And German Hobart, he realized very big rockets, he realized. So these supporting people, if you see, the Korolev is the man who put the first Sputnik satellite in the orbit. So he is the father of the modern space program of Russia. And von Braun, a German who settled in America, he made the Saturn to put the man on the moon. And in India, Vikram Sarabhai came to start the space program. So these are the pioneers and visionaries who have made big impact in the space program. So all this about the space, you want to study the space, you need a telescope to go far, and then it should see far. So the first important telescope is called Hubble. This Hubble telescope gave a lot of information about the universe. And today we have one more telescope. This is called the James Webb. This can see much, much better and far. So you see the telescope first launched by Space Shuttle, the Hubble. It was weighing 11 tons. This Hubble telescope was 11 tons. It was put in the orbit and at a speed of 759 kilometers per second, 7.59 kilometers per second. And it's a very long, 13-meter long, 4.2 meter diameter. And this telescope was launched in 1990 by Space Shuttle. You can just see the Space Shuttle launch, how they put the satellite.
And we have a go for auto sequence start. Columbia's onboard computers have primary control of all the vehicle's critical functions. T-minus 20 seconds and counting.
Kennedy Space Center, USA.
15 seconds. 11, 10, 9, 8, 7. We have a go for main engine start. 5, 4, 3, 2, 1. We have booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
Houston now controlling the flight of Columbia, the international research mission finally underway.
Roger, roll, Columbia.
Columbia now rolling on to the proper azimuth for a 39-degree inclination to orbit. Shuttle.
So this, we'll see all these things later. But what I'm trying to tell you is the telescope is a very, very important thing to understand the universe. These inputs were sent to an organization called CERN. It's a Center for Nuclear Research. It is situated in Europe, and they have got a very large Hadron Collider. This is the one. Well, you can see it generates particles. This is the particle generator. Particle goes around 26 kilometers in a circular path. And this is a circular path. What do you see? This is a circle. What you have? And it is under the ground, deep under the ground. And it is connecting Switzerland, Italy, and France. 3 countries it is connecting, this circular path connecting. And they generate the particles and send through the particles at very high speed. Their intention is to find out the God particle. The whole universe started from a God particle. Glow came. How that glow came? What was the particle? That's a study they want to do. So they have got the whole analysis done. They have found out neutrino. There's one particle which they have found out during the study. It's called neutrino, which is also going at a speed of the light. Neutrino also can reach the light speed. So no particle so far has crossed the speed of light. That is their finding so far. So to have that sun big organization, in the front of the organization, they kept our Nataraja, because they believe that the cosmology started from the Nataraja. They believe that's why they put it. So this is a very important station where the real study is going on, and they have come out with the theory of Big Bang. What is Big Bang? Theory of Big Bang is talking about the universe. So this is the Big Bang. What you see here is the globe. This globe is the one which started the whole universe. Okay. The globe, what happened? The globe was there for quickly it made into, spread as a microwave. And then for 400,000 years it was there, a disk like this. And then it's quenched. Nothing was there for 400 million years. Nothing was there. And suddenly the stars started coming in here. Stars started coming in. Then the stars started aligning, and slowly galaxies came. And now today, this is the diameter of the universe. And it is like a disk. You are seeing with reference to time, you are seeing. So today it is like this, the universe. How many years have gone? 13.8 billion years have gone. From the globe to now, 13.8 billion years. Who said that? The sun, after their studies, based on the input given by the telescope, Hubble telescope, they have estimated the life of universe so far is 13 billion years. The universe, what is the universe? Universe encompasses all of space and time, including all matter, energy, and the physical laws that govern them. It is a vast and dynamic entity, constantly expanding since the Big Bang. The universe contains galaxies, stars, planets, and countless other celestial objects, all separated by immense distances. The universe is 92 billion light years across. What is the diameter? If you see the diameter, it is 92 billion light years. What is a light year? Light year is 9.4 trillion kilometer. 1 light year is 9.4 trillion kilometer. What is the diameter of the universe? 92 billion light years. You see the size of that. That is the universe. So if we can travel in the speed of light, you can go to all places. Every star you can see. Because once you go to the speed of light, your age, your weight, nothing is counted. So if you speed of light, you should go. What is the speed of light? 3 lakh kilometers per second. If you can travel at a speed of 3 lakh kilometers per second, you can travel all the time as you like, and you will remain same. You can see all the stars and come back. Okay. So this is the universe. What does it consist of? It consists of dark energy, which is 74%, this blue, and dark matter, which is 21%. So 95% is over. 5% is the normal matter. Out of 5%, 4% is hydrogen and helium. So remaining 1%, 5.5 is the stars. 0.5, 0.3 is the neutrinos. And remaining 0.2, there are a number of things. And 0.03 is the heavy elements. What is the heavy element? The so-called planets. All planets put together, trillions of planets in the universe put together is 0.03% of the universe. So you see, think of what will be the percentage for Earth. If you see, it is not, you can't count it. So we are very, very small people in the universe. So why the universe is expanding? It is expanding because of the dark energy. Dark energy continuously from the globe, from the Big Bang, is going on increasing. And now it is increasing very fast. So that is because of the dark energy, it pushes the whole thing diverging. So universe is now like this. This is the universe now. There's another thing, dark matter, which I told you. The dark matter keeps all the galaxies together. The stars and galaxies are remaining as it is because of the dark matter. That means suppose you take our Milky Way, all stars of Milky Way is intact, and they are moved together. All the things, they move together at a very great speed. So you see the Milky Way. This is the Milky Way, which has got different arms. And let us understand the galaxies now. There are different galaxies, and we are in the Milky Way. Milky Way is here, the Milky Way. And if you look at the Milky Way very carefully, there is a black hole there at the dot center. It is called central black hole. And this is the whole yellow portion, what you are seeing is called galactic bulge. And then it is all molecular clouds are there. And then arms, it has got arms, 4 big arms are there. And you are in one of the places here. This is the Orion ring, that Orion ring, where you can see the sun, a small dot you can see. So this is our galaxy. And the galaxy arms, you can see the different arms are there. These are the 4 main arms. 1, 2, 3, 4, 5 arms are there. And then this which I told you, and sun is there in the Orion ring. So this is a black hole which has been observed in our galaxy. The Milky Way has got recently they have found one black hole. The object is locked in orbit with a star about 13,800 light years away from the Earth. From the Earth, this black hole is 13,800 light years. 1 light year is 9.4 trillion kilometers. So that is the distance we are talking about. So this is the galaxy. And the Milky Way galaxy, which is 13.2 billion years old, 13.8 billion is the universe. 13.2 billion is our galaxy. And then sun got formed, that is later, 4.6 billion years. And then the planets. And the planets, if you very carefully see, some planets are inclined, different formation is there. You can see it rotates. Mars, it rotates like this. It has got an inclination of 25 degrees. Earth has got 23.4 degrees. And Neptune has got inclination. But if you see Jupiter, it is vertical, no inclination. Saturn has got inclination. Uranus is in the other direction, inclination in other direction. It rotates opposite. And Venus also rotates opposite. And this is Mercury. So all these, I think this is vertical. You see that vertical? This is when Venus is vertical down. So once it is like this, it is not livable. Only inclined can be livable. But Neptune and Saturn, they are gas. This is solid. Earth and Mars, they are solid core. So living planet is only these 2. Okay. But there are moons of Saturn. They have got the same solid formation like Titan, which is also livable. So this is moon. From moon, if you see the Earth, it will look like this, a bluish dot. So how this Earth got formed and why it has got this inclination? 4.5 billion years before, the Earth was struck by another planet called Theia. Theia, Theia. This is a planet with the sun. So it was like Mars. It hit on the Earth and went inside. The particles which came spread around like this. Because of the heat, the Earth axis, which was vertical earlier, got inclined. It was 23.5 degrees at the hit point. Now it is 23.4 degrees. This Earth got cooled after the heating, and the particles which came out, they started moving around the Earth and they formed the moon. Moon has nothing, no atmosphere, nothing. But Earth has got atmosphere. It got cooled, water came, and we are now seeing the Earth livable. And because of this inclination, we have got the 4 seasons. So this is how the Earth got formed. And after the formation of the earth, life started. Life started around, really around this period, small things started coming in the water and land emerged from the water. And 2 billion years before the life started, and around 0.5, that is 500 million years before, you are these all bigger mammals and started coming in, and around 0.2, that is 200 million years before the dinosaurs came, and 65 million years because of the hit of the asteroid, all the dinosaurs died and many species died. Now, 200,000 before this first human being came, and then slowly they got developed. That is 200,000 years is the human life. And this is what the earth is. So if you look at it, 13.8 billion years old universe, Milky Way is 13.2 billion years, Sun is 4.6 billion years, solar system is 4.5 billion years. Now, if you look at the Earth, Moon, Sun system, this is the Earth, this is the Moon. Distance between Sun, Earth and Moon divided by the diameter of the Moon is 108. In the distance, 108 moons can be accommodated. Between Earth and Sun, if you see the distance divided by the diameter of the Sun is 108. 108 suns can be accommodated in this distance. So this 108 is a holy number. So Rig Veda says 10,000 BC, that means 12,000 years before, Rig Veda told about the diameter, told about this 108. It's all there in our literature. So you can see the diameter, all these things have been told 12,000 years before. Who knows how they measured? But all things are correct. So Carl Sagan also agreed that everything is correct in the Hindu mythology. The whole thing has been, even the life also has been told correctly. Now, if you look at this earth, this is the sun, earth. Because of the inclination, you get the 4 seasons. So the tilt has helped us to live happily. And every 40,000 years interval, the earth's axis changes slowly. And the shape of the orbit changes. Orbit also changes. 100,000 years once. So it's all slow changes, but it happens. So it takes 365 days to go around the sun, and the sun goes around in the galaxy 250 million years. It takes for the sun to go around the full galaxy. So Einstein brought theory, the theory of relativity, and he said time is very important element, the 4th dimension, to space, energy and mass. Speed of light remains constant. Faster you move in space, slower you move in time, and your life will not be counted if you can go in the light speed. Time slows down around heavy objects. Gravity is the curvature of space-time. Gravity travels in the form of waves. You can see what he has done. Time is the 4th dimension. He has given a dimension to the time. Light speed, he has talked about light speed. And then the faster you move, your slower you will be moving. Faster you move through space, slower you move through time. Gravity is put that is a wave form. Space and time is a curvature, and there's a gravitational wave between the two black holes or two stars. When they meet together, the wave is created. All these things he told. So out of these theories, many have been proved. Today we have got a proof for gravitational lens and gravitational waves, and we have got the proof of the time dilation. Black hole, this theory has been proved. 2 things have not yet been proved. One is called wormhole, another one is the white hole. These two which he has told is yet to be proved, otherwise all other theories he propagated have been proved. It's a very important theories he has told much before, and one by one getting proved. So if you look at the whole universe, it has got four forces. We normally know about the gravity. Gravity is the one important force. Gravity is the attraction between two objects and which have got mass or energy, like the moon causing ocean tides on the earth. Gravity. Now, electromagnetic force, another one, because everything is a magnet. So electromagnetic force acts between charged particles, like negatively charged electrons and positively charged protons. So this happens between the planets to planets. It's not only the gravity, electromagnetic force also keep them in balance. Then there is one thing called weak force, which is a force which we call the nuclear. Is a weak between the particles. So responsible for particles decay. The force causes radioactivity and plays vital role in the formation of the elements in stars and the early universe. Whatever formed the various elements which have been formed on the stars and then the planet, mostly on the planets, they are all due to the nuclear weak force. There's a strong nuclear force. This is the strongest in the fundamental forces. It is 6,000 trillion times stronger than the force of gravity. 39 zeros after 6 times stronger than force of gravity. So this is a very important thing. That whole thing is kept, the whole universe is in balance. Everything moves, everything goes, but they are not fighting with each other. They are going. All these things are balanced by these forces. So these four forces are called fundamental physical forces of the nature. Then other important theory is called string theory, where you see that all matter and energy in the universe is composed of tiny strings. How these strings propagate through space and interact with each other. You can see this is the formation. This is the actual photograph of the universe. If you see, even though we say dark, you will see all strings are there. One of the many vibrational states of the string corresponds to the gravitation. This is the vibration leads to gravitation. So these are called the quantum theory came out of this. So the quantum gravity, what we talk about, is the string theory. So gravity, electromagnetic force, strong and light nuclear forces act together in the form of strings. All forces act through in the form of strings. This is the string theory. So now let us understand what will happen to a star. How the star got formed? All stars come from nebula. So nebula is the one which generates the stars. It generates small stars like sun or big stars, a massive star. Sun, what will happen? After its life is over, his life is about 8 to 10 billion years, 4.6 billion years it has crossed. It may live for another 4 to 5 billion years and it will die. When it dies, it goes, you see that how it becomes? It becomes a red giant. Then it diffuses to a nebula, another nebula, planetary nebula. And then become white star is a dwarf. It's called white dwarf and black dwarf. So it finally, ultimately, not a black hole, it becomes a small black dot, which is not that powerful. But the big stars, the massive stars, they become a supergiant and they form the supernova. This also can generate stars. Then supernova, there are two possibilities. It can become neutron star or black hole. So very big stars only become the black hole. So this theory came out of Chandrasekhar Subramaniam, is our man, Indian, who found a theory called the mass theory. That is, this is the mass of the sun, 2.765 into 10 power 30 kilogram is the mass of the sun. 1.4 times the mass of the sun, he puts this root. They will become white dwarf. If it is above, only they can go into the black hole theory. So he says, he has put a limit, 1.4 m the times the sun's mass is the limit, and lower than that, it can become only dwarf. Bigger than that, it can become the black hole or neutron star. So his theory was on neutron star, for which he was given the Nobel Prize. So this is a black hole. How the black hole looks, you see the black hole, it looks like this, black hole. Now, what it contains? There are 5 things it has got. One is this, the whole surface surrounding the thing, very effective one. They are called accretion disk. So it's a gas, superheated gas, high temperature. Then it has got the proton sphere, which is very close to that, is called proton sphere. Then it has got a center point, which is called singularity, in the very center of the black hole, where matter has collapsed in a region of infinite density. And then everything goes down to a event horizon where they settle down. Anything it has absorbed, like a star it has absorbed, the star will go down and it will settle down there. So this is a radius around a singularity where matter and energy cannot escape the black hole's gravity. This is a point of no return. And whenever this happens, when the stars are absorbed by the black hole, jets of particles and radiation that blasted out near the light speed, it comes out. So these are the 5 major elements of a black hole. So whenever it goes down, now the new theory is wormhole takes it out and white hole ejects out. So this is a theory which is not yet proved, but that is what Einstein told. So now how you find all these black holes and theories is because of the telescope. There's a new telescope, which James Webb telescope, which is very, very huge, and it has got mirror. This is the mirror. What you see is the mirror, segmented primary mirror and secondary mirror. So this is very powerful mirror which can see far away. What it has done, it has found out the farthest star. Now, comparison with this Hubble telescope. Hubble telescope is mirror is 2.4. This is 6.5 meter diameter. And this mirror mass itself 6,200 kg. This is a very small. Total weight is 12,000 kg. That is 12 tons. And this is a very huge one. This must be more than 20 tons. So this is James Webb. Now you see that it has given pictures of stars emitting out. You can see from the nebula, stars are coming out. The generation of stars, it can identify different forms of universe. You can see these things, and this is the lens. It's called lens, that is gravity lens. All these things it has found out. One important thing it found out is the farthest star. This is very important. The star's actual distance is 28 billion light years. Distance is from Earth, it is 28 billion light years. See that number. And his age is 12.8 billion years. So when you say 13.8 and nearly 1 billion year, it was not active. Stars started coming in only after 1 billion years. see, it has found out that 12.8 billion years. That's why we are hopeful that the analysis and the study of 13.8 should be right. But the people are contesting that. People say, no, it is must be more. So the remarkable feat, NASA's James Webb Space Telescope has unveiled an image of the most distant star named Earendel, employing the innovative technique of gravitational lensing. This is a great finding. Another important thing it found is the TRAPPIST. This TRAPPIST is a star, TRAPPIST 1. It has got 7 planets. Each planet is almost equal to the Earth size. Okay? And you see, this is the star, and this is seen from the planet. This is one of the planets. They say that water can be. See, these are the photographs which are coming. Some of them are artist views inferred from them, but it's 40 light years away. These TRAPPIST planets are there. Now, the latest finding is 95% possibility of alien life in this planet. Aliens are there. That is the finding. There's another planet which is Proxima b, which is 4 light years away from us. That is also possible for living. So these are the findings from the telescope. So now we have seen space is a very important thing. We should study more about. For studying, you need telescope or satellite to go or spacecraft to go, and they can be launched only by a rocket. So a rocket is a very important element in the whole study of the space. Unless you have a rocket, you cannot put a satellite in the orbit. Satellite goes in the orbit. Satellite sees the pictures it takes, or it does the communication. Many applications are there. For doing that, you need ground stations, mission operations, and then you need number of stations to monitor the satellite performance. So these are the totally is called rocket science. When we talk about all these things, we are going to study a rocket. What is a rocket? How it got evolved? Then what is the principle of the rocket? What are the systems in the rocket? What are the technologies involved in the rocket? How do you design the rocket? And what are the importances of the ground stations and the launch stations? How they make things different? And what are the different types of satellites are there? What different types of orbits are there, and how the satellite is going around the orbit constantly? It is going, it is not falling. Why? And then how do you put the satellite in the orbit? How do the people work? Mission operations. And then what are the different ground stations involved? All these things we are going to study. In our different classes, we are going to see. That is the course which we are going to do. So this is an introduction to you to go before the rocket. So thank you very much. So this is the first class where we talked about space, universe, and what does it contain, and where is the our galaxy, and what our galaxy is doing, what is black hole, and where is the sun in the galaxy, and what are the different planets we have, and how do we live on the earth, how the earth got formed and got inclination and the 4 seasons, all we have seen. Okay, thank you very much. Now you can ask me questions to clarify the points.
Yes, sir. Thank you so much, sir, for the first session. So it's open up for the question and answer session. So maybe the students can raise your hand so that our team will allow you to ask the questions. They will make you to be a presenter so that you can unmute your audio and you can ask. So when you're asking the question, you can just say your name, which standard and school and place. So then you can put forth the question. So it's open up for the question.
Good evening, sir.
Yes.
Sir, my name is R. Ananta Padmanabharam. from Javara Higher Secondary School, Neyveli, Tamil Nadu, sir.
Okay.
Sir, like in our Diwali rockets, we can ignite our rockets. So how rockets are like PSLV, GSLV ignited, and how rockets are separated automatically.
We will be studying that. Okay, you wait for that answer in the class.
Okay, sir. Can I ask one more question, sir?
Yeah.
Sir, how students can launch their own nano satellites in Earth's orbit?
Now, question should be on the class. Okay. Today's
Okay,
class,
sir.
those questions you should ask because each class will contain certain material where you should ask the questions. What you
Okay,
are
sir.
asking is for later classes.
Okay,
Everything
sir.
explained to you.
Okay, sir. Sir,
Okay. Next question. Next.
you told
Uh,
Sir, you told that when we release the balloon, it will fly. Like that, if we, you told that rocket works on the principle like that. So, if we release the balloon, it will go. It will not go straight. It will go left and right. But how rockets are launched straight, sir?
okay. Okay. So next question.
Sir, good evening, sir. My name is.
Your name is?
Yeah, you can ask. You can unmute and you can ask.
Sir, am I audible, sir?
Yes, yes.
Okay, sir. Sir, my name is R. Sanjeev Kumar and I am from Velamal Vidyashram, Surapet, sir. Sir, and my question is that as Albert Einstein said that the speed of light is constant, then why does light seem to slow down when it is refracting or in a different medium, sir?
Because of the medium only. Effect of the medium. And he talks about the the wave form. Everything is in the wave form. So suppose there is a one planet comes in between the light. The light will bend and then come to us. Suppose we are seeing different stars you are seeing, but in between there could be another star or another planet. But the light will itself will bend and reach us. That is the capability of the light. That's what he said, and it is true.
Yes, sir. Sir, can I ask another question, sir?
No, ask. No introduction is required. Go on shooting.
Okay, sir. Sir, what factor determines whether exploding star becomes a neutron star or a black hole, sir?
Size of that star. Mass. So, that's what Chandrasekhar has defined. Size.
Like you mentioned that bigger stars either turn into a neutron star or a black hole.
Or a black hole, yes.
So even that is determined through size of the star, sir.
Size means huge, millions size. A sun is a small star. Okay.
Okay.
If you have got millions times the size of the sun, it will definitely become a black hole.
Okay, sir.
Size.
Okay, sir. Why the James Webb operates at minus 230 degrees Celsius?
See, it's not that way. You are going far inside, Temperature will vary.
Okay, sir.
If you go in an aeroplane, the pilot says minus 40 degree, right?
Yes,
he says that. So it's minus 40 at that altitude. Similarly, when it is moving up, the James Webb is going deep into the space. So the temperature varies there. That's why it's minus. It should function. It should function at minus 230 degree centigrade. That's the reason for that.
Okay, sir. Sir, why are the planets that are tilted at an angle are only livable, sir?
That is because of the seasons. If you are flat, what happens? Sun always attacks you. Other side, sun will not be there. You can't live.
Okay, sir.
So the flat means the seasons are not coming. So if it rotates, it will rotate, but you will get the sun also, but you will not get the season. The temperature variation will not come.
Okay, sir.
Because you see that North Pole, when it is winter, South Pole is warm, you know.
Yes, sir.
You are seeing the difference. So the 4 seasons are possible only because of the tilting. 4 seasons gives you a pleasant life.
Okay, sir.
That's the reason. Next person.
Thank you. Thank you very much, sir.
Sir,
Yes.
sir, I'm Darshan Raj, studying 11th standard from Javagar CBSE school. Sir,
Yeah, your question, my
Speak.
question. Ask your
Speak.
question.
sir, you told that black holes are absorb all stores and energy even, but how it will release the light energy after it absorb?
No, when it is coming towards that one, when the star is attracted by the black hole, when the star is coming through near to that, there's a light emitted. That's what I showed you, that light get emitted because the star is diffusing. The stars get diffused because of the pull. So because of the diffusion, light comes out.
Sir, my question is why the black hole did not absorb that light?
Black hole, see, it's outside that light. Once it has gone inside, nothing will be there. No light will be there. Everything is absorbed by the black hole.
Okay, thank you, sir.
Thank you.
Sir, I am Anish Efrain, studying 11th standard from Javaga Higher Secondary School, sir. Neyveli, Tamil Nadu. Sir, I am audible?
Yeah.
Yes.
Sir, what is the difference between a planet, a star, or a moon and a moon? What are the major difference does a planet, a star, and a moon have, sir?
Star is a part of the galaxy where it has got the original thing. For example, the sun, if you take, sun is a star. Why it is called a star? It is controlling 95% of the gravity pull it gives to the planets. Planets are what? Planets are the disciples of the star, which is attracted by the gravity of the star. So the main gravity is with the star. So stars attract planets. So they are all there. Is there one unit? When you call star, planets, they are one unit. Number of stars is one galaxy, that's one unit. So galaxy, when you say, it consists of trillions of stars. Each star has got their own control, which is when if you want to understand that, it is a nuclear force. Sun consists of helium and hydrogen. It is a fusion energy. Fusion energy is nuclear energy. It is nuclear, but the planets are not nuclear. Understand? Planets are around,
Yes,
is attracted by Earth. 95% of the gravity of the Earth is controlled by the sun. That is why it is going in a particular orbit. Suppose the control is not there by the star, Earth can go anywhere. You know?
Yes,
is it
sir.
clear to you? The moon is the subordinate of the planet.
Thank you, sir.
Okay. Moon is called artificial satellites, you know, no? Moon is a natural satellite. Next question.
Sir, good afternoon, sir.
Good afternoon. Bharati. Question.
Sir, I want to know what is constellation, sir?
Constellation means something together. Suppose you say a constellation of stars. In a galaxy, there are stars, you know. The whole stars is called constellation. They are group. Constellation means group. Our DMK party is there, you know, DMK party.
Yes, sir.
You know, that's all the people who are working in the DMK party, they have got MLAs. That's constellation.
Okay, sir. I want to know about what is my dark energy, sir.
What is the?
I want to know about what is my dark energy, sir.
See, the whole universe is dark.
Okay, sir.
When is the dark, there is some force acting to make things moving. That
Okay,
means
sir.
energy. When something is moving means somebody is pushing, is not? That
Yes, sir.
pushing is done by the dark energy. You can't
Okay,
see
sir.
the energy. You can't see that. The whole universe is dark. You can't see that. But at the same time, you are seeing somebody is pushing. That is called dark energy.
Okay, sir. I want to know whether you said white hole is true or not, sir.
That we don't know.
Once I want to know dark hole is a loop only, no, sir.
What?
I want to know dark hole is a loop only, no, sir.
Dark hole.
Yes, sir.
What is dark hole?
Dark hole you told, no, sir. So inside
Black
that
hole.
is a
Black hole.
black hole only, sir. Inside that is loop only, no, sir.
You sir, you leave. I say only sir, I am hearing. Question you ask.
Sir, question is whether the dark hole is a loop or not, sir.
Loop. I don't know. Is a guy. See, it's a black hole. Hole, you know, hole.
Yes, sir.
You've seen that basketball, you know. You put the
Yes, sir.
basketball in that ring, you put that hole. It's like that.
Okay, sir.
It's a hole.
Okay, sir.
Okay. Next question.
Thank you, sir.
Hello, sir.
Yeah.
I'm audible.
Yes.
Myself, Ilakia from Velamal main campus, sir.
Okay.
And my question is, how do scientists calculate the diameter of the universe when we can't see the whole thing?
See, good question. See, you have got a telescope, right?
Yes,
And
sir.
the telescope is finding the galaxy moving, stars moving, galaxy moving. Then from the movement, from the distance it moved, they calculate the speed. They calculate the distance. You know, a telescope can find out the distance of the movement with respect to time. Correct?
Okay,
Right, is not? So once they know the distance, then they calculate for the farthest star.
Oh, okay, sir.
They take the farthest galaxy, farthest star they take, and then this side they take, all available in the telescope. Telescope is seeing everything. So from that they calculate.
Okay, sir. Thank you so much, sir.
Thank you.
Sir, I am S. Adhavan, sir, from Taira Matriculation Higher Secondary School, Tuthuraipundi, sir.
Okay.
Sir, my question is, which country launched Hubble telescope, sir?
USA, NASA. NASA. I've shown you space shuttle. No, space shuttle I showed you. Space shuttle launching the Hubble telescope I showed you. Space shuttle belongs to NASA, America. Hubble telescope belongs to NASA, America.
Okay, sir. Thank you, sir.
Thank you.
Sir, my name is Sheikh Adil, sir. I am from 9th standard Velamal Matriculation School in Chennai, sir. Sir, is it possible that the supermassive black hole present in the center of the Milky Way galaxy is actually formed from a very old supermassive star which went a supernova? Is it possible, sir?
Correct. Yes.
Oh, so the dust that was formed after the supernova led to the creation of the whole Milky Way galaxy, sir?
No. See, the sequence is like this. First stars came. Stars assembled to become the galaxy. From galaxy, after it comes, the stars, whichever stars are there in the galaxy, they started dying. Bigger stars, when they die, they become black hole. That's the sequence.
Okay, sir.
Okay, nothing starts from this black hole. Now, after the black hole has come, black hole can generate stars. But they cannot generate galaxies.
Okay, sir. Understood. Thank you so much, sir.
Sir, excuse me, sir.
Yes.
I am Pranav, class 11 from Agathiar School, CBSE. I have a doubt. You said that planet Theia attacked Earth. Is that proved or it is just a theory, sir?
No. It's not a theory. It is proved. See, because when you study the sequence of formation of the sun and then the formation of the earth, earth was just a disk initially, a barren disk. Then this Thea hits, then it gets inclination. Otherwise, the inclination would not come. Then it's started coming, water coming, atmosphere coming, all these sequences there. So if you see the internet, you ask a question, formation of the earth. Okay. And there's a video will come, how the whole thing got formed. There you can find out how the sequence is. This is not guesswork. It is a actual with the records they have got.
Okay, sir. Sir, I have another doubt. Sir, the speed of universe is speed of light, sir?
No, speed of universe is much more than light speed.
Okay, sir.
The
Thank you,
energy,
sir.
dark energy can push things at a faster rate. So the glow which has come, the God particle glow which has come, it has pushed everything at a greater speed than light. That is why they are trying to find out what is that God particle which has given the speed more than the light speed. That's what people want to find out. That is why the sun was created.
Okay, sir. Thank you, sir.
Sir,
Harshada.
Yes, sir. I am from Yasashida from Sairam Institutions in Chennai. I have a doubt, sir. What is the doubt mean?
What is
Doubt,
the?
sir.
Hello, sound changing. What is the question?
You have told that rocket had a bottom in a chamber. What the chamber will do, sir?
Not clear.
In rocket, the rocket
Your sound is changing. Your
chamber,
sound
sir.
is changing. Sound varying and it's not constant. Speak closer to the mic.
Now I am audible, sir.
Your voice is not audible, ma.
Next person. Next person. Next person.
Next question.
Sir, I am Kaushik from E Road, Konkakalyalayam, sir.
Okay.
Sir, according to the Einstein theory, he said that time and space are interlinked like a three-dimensional fabric. Can you explain deeper how it is interlinked?
4 dimensions are there. No. What it is not my theory, it is the Einstein theory. What Einstein is saying that there is one element called time. You have got space. You know space. We normally talk about energy, gravity, and all those things. But when you see the space, it has got a dimension that is time. Everything depends on the time. That is how today we are able to estimate the time of the universe because of his theory only. The time element comes. How the time element comes? The telescope tells that. When you put a telescope, when it moves the stars, when they move, there's a time, it takes certain time to move to a place, to the space. That is why the time element has come. So they correlate between the movement speed, distance, and time. All are coordinated. No? From that only they find out that the time and space is a very important element in the universe based on the movement of the galaxies.
Yes, sir. Thank you, sir.
Next question.
Good evening, sir. Now I am audible, sir.
Yes, audible.
Sir, you had told that the rocket had a bottom that called as chamber. What will the chamber do, sir?
Chamber, we will see that in the rocket class. We have not come to the rocket. I am only trying to give an introduction today. We are going to study the principle of rocket, how the bottom is, everything we are going to see later. Okay.
Okay, sir. The another question is, Mars is a live planet.
What is the?
Mars is a live planet.
Life planet.
Life planet.
So Mars is the life planet.
What is light planet? I have not told light planet.
Live, sir. L-I-V-E, live.
Live, live. Live planet. Life.
Yes, sir.
Planet which has got life, you are saying. Like Earth. Earth is a planet with life. Is it that you are saying?
Yes, sir.
Okay.
No,
So there
she's
is.
asking Mars is live planet like that. So it's a Mars.
Okay. So if you see the arc of livable planets, there are planets, more than 5,000 planets have been studied. They are in the living zone. There's a living zone. The living zone, if any planet is there, life is possible. Okay. Now, if you see Earth and Mars, life is possible in these two.
Okay, sir. Thank you, sir.
I have not answered it. So like that, there are so many planets are there. In these planets only, I told about TRAPPIST. Then, like that, there are a number of planets are there which are livable. Mars is livable.
Yes, sir. You have shown some planets in screen.
Yes, correct. Okay.
Good evening, sir.
Yes.
Sir, I'm Kaushik from Jaira Metric School studying 12th, sir.
Where is the school?
Sir, in Salem, sir.
Salem, okay.
Sir, my question is that which theory explains gravity better, sir? Newton's theory or the Einstein's theory?
No, there is a difference between them. Newton said gravity is depending on the mass.
Okay, sir.
Okay, mass is, he has given a formula G m1 m2 by R. Is the gravity he has given a formula. Einstein says no, that's not correct. It is the energy which is important. So there is a difference of view between them, but both are right. If you take under the Earth situation, you take Earth, Newton is right. You take universe, Einstein is right.
Okay, sir. Okay, sir. Thank you, sir. That's all.
Okay. Next.
Hello, sir. Good evening, sir. I'm Harini from Tamil Nadu, sir, and I'm studying in the St. John's School, sir.
Where?
And my doubt, is that,
St. John's where?
sir, from Madurai Kochadai, sir.
Oh, very good. Another question. Very good.
Sir, we have huge planets in our solar system, sir. Like the last 4 planets are huge planets, and only the huge planets have rings. As long as I have noticed, the largest planets of our solar systems have rings, and also the gaseous planets of solar system have rings, sir. So does the Mars have any role to play with the formation of rings?
No, the Mars is a solid.
Okay,
Mars.
sir.
Earth
So
is a
no, sir,
solid.
Mars. I'm talking about Mars, sir. Like the mass of the planet. Yes,
Mass of the ring, you are saying.
Yes, sir. No, sir, the outer planets like Jupiter, Uranus.
You take Saturn. You take Saturn. Saturn
Okay,
has got rings, you know.
Yes, sir.
Yes. So what? That's
No, sir. Does the formation of rings depends on the mass of the planet, sir?
No.
Okay.
No. It is not like that.
Okay,
this is a natural formation. You see that the Saturn, compared to Saturn, the Jupiter is heavier, bigger.
Yes, sir. Yes, sir.
But you see clearly the ring only on Saturn.
Yes, sir.
It is not the higher mass. It is not the higher mass. So the ring formation is based on the gaseous flow.
Okay, sir.
So the gas flow around that, which is which with certain particles, is going around. Have you seen the Saturn through telescope?
No, sir. I don't have any access to telescopes.
No, you should go to one of the Coimbatore you got.
Okay, sir.
Chennai, our Periyar Center is there, where the Science and Technology Center, where they have got the a long telescope they have got.
Okay, sir.
Through which you can see the Saturn, and you can see the beautiful rings you can see.
Yes, sir. Yes, sir.
So it's an amazing sight. You
Yes,
must,
sir.
one day you must come to Chennai and
Okay,
see through the Saturn. There are certain times they align themselves.
Okay, sir.
They announce the visibility.
Okay, sir.
Sometimes they say Jupiter is visible. Sometimes they say Saturn and Jupiter both visible. I went there to see when they called me. I
Okay,
saw
sir.
all these planets in one line.
That's
And
amazing.
everything was glowing like anything. Well,
Yes, sir. Yes.
everything is dark, but they are all glowing. Very beautiful sight.
Of course, sir. Sir, I have another question, sir.
Ah.
Sir, we have black holes very far from our planet, sir, from our galaxy. I mean, yes, we have black holes inside our galaxy too, but it is not up to our reach, or we can't reach them through any other sources. But we can still figure out how a black hole works and what is the principle of it.
Telescope.
How it is.
Telescope. The telescope could see deep into that. That is why that the Hubble telescope and the James Webb, they are the very important sources we have got. Today there are more than 10 telescopes are there.
Okay, sir.
Like C.V. Raman telescope, all names you can see. Many telescopes are there. But these two telescopes are very good. They have given a lot of information. The black holes have been seen. The photograph which I have shown you is the actual photograph.
Okay, sir. Okay, sir.
It is 13,000 light years away from us.
Yes, sir.
You can't reach them.
Okay, sir. Okay, sir. Thank you, sir.
Thank you. Any other question?
Students, unmute yourself and ask the questions, man.
Hello, sir.
Yes.
Good evening, sir. I am Adithan from Sairam Medical Higher Scientist School, Tiruthurai. Meeting a legend like you is a moment of pride to me, sir. Shall I ask the question?
Yeah, ask.
Sir, how do you imagine rocket science blending with AI and robotics to create next generation of space mission?
Rocket science and next generation robotics.
Blending with AI and robotics.
Yeah, it is there. We'll talk about it. We'll talk about the rockets and then the purpose of the robotics in rockets, purpose of AI in rockets, all will come in your studies, it will come.
So, sir, another one question, sir. So, what is your vision for India's role in advanced technologies like hypersonic missiles and space exploration over the next 20 years?
Okay. We'll see. You are asking a question which is going to be covered. This is not the only lecture I am going to give. This is an introductory lecture
Okay,
only.
sir. Okay.
Hypersonic and all
Yes,
will be
sir.
talking later.
Yes, sir. Okay, sir.
So reserve your question, okay?
Thank you, sir.
You ask me when I am talking about hypersonic.
Yes, sir.
Good evening, sir.
Good evening.
I'm Niranjan from KSR School, Mudachalam.
Okay.
Sir, you spoke about CERN CERN, whose mission is to find the God particle. So, sir, is it that only one particle has developed into this big universe?
No. What they do is, see, the particle theory. What is particle theory? You can generate particles. Is a physics. Generate particles. You can generate from an atom. Okay, atom has got what? Proton, electron, and a neutron.
And neutrons.
So from that you can generate various particles. So electron will be moving, proton will be moving, neutron will be moving, everything will be moving. So these are all particles. These are all going. Similarly, isotopes. They split isotopes and generate particles and then generate that. There's a generator. I've shown you the photograph. That generator makes the particles. Then they pump the particles at a very high speed. So there is a circular the movement of the is a vacuum, but because you are pushing it, the particle goes at a very faster speed. Then the speed is camera. They have kept 26 kilometers. Different places they have kept the camera. The camera measures
sir.
the speed of the particle. So
Okay, sir.
then they want to find out which particle has got speed more than the speed of light. That is what they want to know. So they generate particles and see which one. That's how they have found out some of the particles have got speed equal to the light speed.
Yes.
Neutrino.
Okay, sir.
Neutrino is a great finding from them. So like that,
Yes.
there are particles which they are saying that they are moving around, but it is within the speed of light. So far, they have
Yes.
not found any particle crossing the speed of light.
Yes. So then it is because of the dark energy the universe has developed over the years, right, sir?
Right.
Yes, sir.
So
Thank you, sir.
definitely there's a particle
Yes, sir.
going at a speed more than the speed of light. That they want to find out. They're not able to.
Okay, sir.
Now research,
Yes.
people are doing research to go to the
Yes.
speed of light. If you can go to the
Okay.
speed of light itself, if you can travel, then you can
Yes,
visit
sir.
all the stars. So there is a
Okay, sir.
propulsion being developed, which I will talk in the later class. What is the type of propulsion one can develop for reaching the speed of light?
Sir. Yes, sir.
Okay.
Yes,
Good,
thank you, sir.
good knowledge.
Yes, sir. Thank you, sir.
Sir,
Ah.
I am Akash from Jawahar Higher Secondary School, Tamil Nadu, sir. I have a question. Is it possible that a star we see today no longer exists because its light took so long to reach us, sir?
No, I am not hearing you.
Is it possible that a star we see today no longer exists because its light took so long to reach us, sir?
Life is there. Everyone has got life.
Light, sir. Light took so long to reach us, sir, from stars. Sir,
what you are asking? Every star has got life.
is it possible that a star we see today no longer exists because its light took so long to reach us?
Yeah, life is over, so we will not exist.
Okay, sir. Sir, I am having another question. What's the biggest challenge in getting humans safely to Mars?
What is the biggest? What is the biggest?
Challenge in getting humans
Galaxy.
Challenge, sir. Challenge in getting into Mars.
What is the biggest challenge?
In getting to Mars, sir. Humans getting into Mars.
Getting to Mars.
Yes, sir.
You want to go to Mars, huh?
Yes, sir.
There's no biggest challenge. Mars rovers have gone. Now people will go.
Okay, sir. Thank you.
There is no biggest challenge. People will go to Mars.
Good evening, sir.
Yeah.
I am Sakitan Saranukeshnan from Bright Red School, Abu Dhabi. I'm currently living in Chennai. So, sir, I just wanted to ask this question. So, what happened in the earliest form of our Milky Way galaxy? Like, what were its forms, and what types of stars and not galaxies, but what types of stars and planets were there in the Milky Way?
The Milky Way got formed 13.2 billion years before. How they got formed? Because the stars collected and then they formed the galaxy. And those stars are there. At the same time, new stars emerge from the nebula, whatever nebula has got. And one stars die, big stars die, they create the supernova. And from supernova also, new stars come. So if you take the beginning, if it is 1 trillion stars, today it may be 100 trillion stars in galaxy, our galaxy. So the going on multiplying.
Yes.
Within the galaxy is multiplying.
Yes, sir. And so, what is the furthest satellite that India has launched into space? Like, what's like the farthest, like the most far satellite right now?
Farthest satellite is our, for studying the sun. We have launched a satellite. Aditya, which is 1.5 million kilometers away from the Earth. That's the farthest.
Okay, sir. Thank you, sir.
Sir, I am
Rajwal Sanjeev from I'm studying in 8th standard, sir. I am from Wales Global School, Mogapet, Chennai.
Ah.
Sir, do really the multiverse exist, sir?
Yeah, this is a debatable point because CERN, CERN, they have come out with a theory of one universe. But there are scientists who say, no, it is not one universe. There are multiple universes there, they say. But whether they can prove that? No, they could not prove that. But they are bringing out a new theory is, that the light from one source, when it goes into another particle, then it can diverge. There's a new theory they are bringing. So they are saying that if you talk about this new theory, it is possible for multi-universe. This is what they are saying. This is called entanglement. The entanglement theory, which has been brought recently, that says, for example, I tell you, you say 1 and 0, 1 and 0. These are called binary numbers. 1 and 0 make a computer, right? We use it.
Yes, sir.
1 and 0 act separately. But when they act together, that is called polarization. When polarization happens, entanglement happens, and they multiply in their performance. This is called the quantum theory. This is what the quantum computer is. So quantum computer is a very enormous capability it has got because of the entanglement. So the same theory they are saying, due to entanglement of the stars, it is possible to prove that there is a multi-universe existing. This is what they say. So these, different theories are there. And so nobody agrees with 13.8 also. There's a dispute on that. Like that, see, each scientist will have his own view. But what is approved today is what CRN says, 13.8 billion years. And one single universe we are talking about. But if you look at our own mythology, if you see, the universe, it comes and dies, comes and dies. So that is depending on the life of Brahma, they say. So many years when he lives, it is there, universe is there. And Brahma also dies. New Brahma comes, then new universe comes. Like that, there's a lot of theories are there. So we can't say which is right. But you have to go by the majority of the scientists.
Sir, I have another doubt, sir. Sir, in this universe, every object has gravitational force, no, sir?
Yes.
Sir, then if there's a car and we are standing, sir, why are not we attracted towards the car, sir?
Car is attracted by the gravity of the earth, which is bigger gravity. See,
Sir,
you see, it's a relative. You stand on the earth because the earth has got the gravity. You don't have gravity for you.
Sir,
You
then the
can't
higher
attract
the
anything.
mass.
You can't attract anything. You don't have gravity. Gravity is for the mass.
Sir, then the higher the mass, higher the force of gravity, sir.
Yes, M1, M2. Gravity means there are two masses. Gravity theory of Newton is based on two masses. Today we talk about gravity of the sun, gravity of the earth. Gravity of the sun is very high, so it is attracted. So earth is attracted by the sun. If you take only the earth has got a gravity, it attracts everybody, everything on the earth. But that is a small force. But big force is that. Bigger force is the galaxy.
Okay, sir.
So it changes. But a human being does not have gravity.
Okay, sir.
It is between M1 and M2, two big masses.
Okay, sir.
Okay.
Thank you, sir.
Sir, myself, Kalai Selvan from Velamal Vidyashram School, Surapet, sir. Sir, you said that Einstein said as faster the object move, the slower time passes. Is it just a theory or else it is proved, sir?
Repeat. Einstein said?
Sir, Einstein said, as faster the object move, the slower time passes. Is it just a theory or else it is
No,
proved?
it has been established.
Oh,
See,
then
I have told you that what are the things proved by Einstein theory proved, you know. There,
yes,
all things have been proved except the white hole and the wormhole. All
yes, sir.
things have been proved.
Yes, sir. Then with this theory, we can able to make a time machine, sir, and we can live more
That is
days.
what he is saying. Time is a very important element. He has only brought the time element. Nobody talked about time earlier. He is only talking about time. So time and space for that moment has got a relationship.
Then it is possible to find the time machine, sir.
Yes, yes.
Oh,
Yes, yes.
okay, sir. Yes, sir. Thank you, sir.
Good evening, sir.
Ah.
I'm Sujibala from Velamal Matriculation Higher Secondary School, Chennai, sir.
Ah.
As you said, CERN is working with atoms, sir. How they give theory about universe, sir?
No, theory about the universe is that, see, everything is molecular based. You know, atom means multiple atoms together, it becomes a molecule, right?
Yes, sir.
So, molecular theory is a very important theory which controls everything. So, they talk about molecular theory and the earth, the physical forces I told you,
Yes, sir.
around the physical forces, they talk about the theory. So that is what they talk about the universe. Universe has got the four fundamental forces which act together to keep things moving. But what is your particular question?
No, sir. I just want to know, like, they researched about atoms. So when we research about atoms,
Atom is anything you take, atom comes there. But we are not talking about atom. We are talking about the forces.
Okay, sir. So when we know, so I have another doubt, sir. Dark matter is essential for the formation of galaxies, sir. As you
Not
told,
formation of galaxies. Dark
Yes,
matter is relevant for movement of the tribes, movement of the galaxies, along with their stars.
as you told, dark energy is making the galaxy, making the universe more bigger and wider, no, sir.
Correct.
So I just want to know whether dark matter is essential for the formation of galaxies.
Let me explain to you. The stars come together and they have formed a galaxy. Now new stars are coming within the galaxy. Galaxy is becoming bigger, but they are bound by their boundaries. That is done by the dark matter. Dark matter keep the galaxy together. Each galaxy is separate. Okay. Now the dark energy is pushing everybody. And when everybody is pushed, that galaxy moves intact because of the dark matter.
Okay, sir.
Is it clear to you?
Yes, sir, I'm fine.
Okay.
Thank you, sir.
Sir, good evening, sir. Am I audible?
Yes.
Sir, I'm Sai Mukundan of Velamal Metric Higher Secondary School in Mogape, sir. Sir, my question is that you told a supernova can create stars, no, sir? How big the stars generated by a supernova can be, sir? How big?
It is, we can't tell the size. It can be anything. When it is generating the star, it can generate a small star or a big star. It can generate. It's up to, we can't really measure because the supernova size is also important. The supernova formation, size, everything is important. A big star, when it dies and then supernova forms, it will be a very big supernova. So then the stars which are coming out of that will be bigger.
Okay, sir.
It's like that.
Thank you, sir.
So my name is R. Rahul from Javaga High Secondary School, CBSE. My question is that how do scientists calculate the mass of a supermassive black hole, sir?
See, calculating the size, to take a star, sun, how they calculated the sun's mass, they see the diameter, okay, the size, the diameter, and then the quantity of the gases inside. Then they calculate the reaction which is happening between the hydrogen and helium. Then they estimate this would be the mass. So relatively, if you see the size compared to a planet, the size of the sun is very big, right? So then they
Yes.
take the size, take the mass inside, then try to identify the total mass. Mass is related to the size and the gas it contains. So that's what they do it.
Okay.
This is an estimate. It is an estimate. Nobody has gone to measure the weight of the sun, but it is an estimate.
Okay, sir. Thank you, sir.
So the same way it is done for all the stars and black hole.
Good evening, sir. I'm Hansika of class 9 from Heartfulness International School, Omega Branch, Tamil Nadu. My question is, you talked about how Albert Einstein has stated a few theories and how they were slowly getting proved. So the white holes and wormholes theory was still unproven. What is the exact theory he stated for the white holes and wormholes?
See that the telescope so far they have not shown any white hole. But the theory is the black hole, when it absorbs the dead stars, stars which are dying, or active stars it can absorb. But those things are put in the under the singularity, they are put inside. Now there is a wormhole connecting the black hole and the white hole. The wormhole is a conduit through which all the substances go and come out to the white hole. And white hole ejects out the stars. This is a theory. Okay. It is not yet proved. Why it is not proved? Because they could not find any proof from the telescope data. They are not seen. Whereas black hole has been found. White hole is not found.
Okay, sir. Thank you, sir.
It may take some time to understand that.
Okay, sir.
Hi, sir. Hi, sir. Myself, Philamati of St. Anthony's Matriculation Higher Secondary School, Neyveli, sir. Sir, am I audible?
Not audible. Okay.
Sir, I am Ilamati of St. Anthony's.
Okay. Question.
Okay, sir. Sir, you said that if a star becomes old, get old means it becomes a white dwarf and a black dwarf. What will happen to the star planets that is interacted with the orbit of the
All
star,
will die.
sir?
All will go mad. All will go mad because stars only connect the planets. If the stars die, planets will not be there. Planets also will. If sun dies, will Earth remain?
No, sir.
No. Where the Earth will go? It will go and hit with Mars. It will die. Everything will die.
Will it leave orbit, sir?
It will be in the orbit. Dead as a dead mass. It will
Oh,
not have any power. It will not have light. It will not have any gravity. It may go mad. It may go and hit with some other planet and the other stars. All those things will happen.
sir, another sir. When I used to stargaze in the sky, I used to see many of the stars moving in a zigzag manner, sir. But it not hit any other stars, sir.
No.
Why?
That is see, you have got a big fellow that is called the galaxy. It has got the gravity, right?
Oh.
So
Yes, sir.
that gravity has put every star in the arm, the four arms.
Okay,
They will not
sir.
allow the thing to go out of the arm because of the gravity. So that is why it is not going out, but it will go in the arm itself. It will, it will be there.
Okay, sir. Sir, another sir, the farthest star Arundel.
Ah.
It's captured by Hubble telescope,
Yes.
sir. It ranges
No, not Hubble.
20.
It has been captured by the James Webb.
James Webb, sir.
Recently.
Okay, okay, sir. But it ranges between 28 billion light years from the Earth. But the image of the black hole, which is in the center of the Milky Way galaxy, is captured by which telescope, sir?
They all by the James Webb.
Oh, James Webb
You can see
telescope.
far. James Webb can see far.
Oh, okay, sir. Okay, sir. Thank you, sir.
Any more question?
Sir, can I add a bit?
What is the time now? 8 o'clock. Okay.
Sir, am I audible, sir?
Only
Sir,
one
can
or
I
two
add a bit?
questions. We should close the discussion. 1 or 2 questions.
Okay, sir, may I audible, sir?
Yeah.
Sir, I'm Atish Weber from class 11, Soil Matriculation, Madipakam, sir. Sir, actually, we know that black holes are heavy objects. So, now what is the minimum distance range where it could pull an object, sir?
It also depends on the size. Black hole size. If it's a big star dying, it will be a big mass. Gravity is more for that. So it can take a star which is, hundreds of or light years away. It can take. But if it's a small star, black hole dying, it may take less. So distance is depending on the size and the
Okay, sir.
gravitational force.
Okay, sir. Sir, I have another doubt, sir. Sir, so if the object is very large distance and the black hole is big enough to cover those distance, would it be able to cover the object?
Which object?
And a planet, sorry.
Yeah, it can cover. It is within that it has got a limit,
Yes, sir.
Depending on its gravity, it has got a limit. Anything coming in the limit, it will absorb.
Okay.
That's why I showed a diagram, that the diagram I have put, that outer, this one. So it comes, anything comes, it will take.
Okay, sir. Thank you, sir.
Thank you, thank you.
Good evening,
Sir, good evening, sir.
Good evening, sir.
Varun.
Sir, good evening, sir.
Ah.
I am B. Varun Kumar of Javaga School CBSE from Neyveli. Sir, what type of fuel or energy sources power space telescopes?
What energy? Energy is solar.
Energy of fuel.
You see, you have got solar power. That means outside power you have got. Okay?
Yes, sir.
It has not gone out of the solar system. It
Yes,
is
sir.
within the solar system. That means it is looking at the sun.
Yes, sir.
It has got sun's radiation, so it has got the solar power.
Okay, sir.
But all the time solar power may not be there. Then it needs to operate its batteries power. So there's both are available.
Yes, sir. Thank you, sir.
Thanks.
Sir,
Good evening, sir.
Sir,
Sir,
good evening.
Good evening, sir.
May I, sir?
Yeah.
Sir, good evening, sir. I am B. Chandra from class 9A, Velamal Vidyalaya Alapakam, sir. Sir, I have a doubt regarding wormhole, sir. Sir, if one wormhole has two places, which one place has weaker gravitational strength and another one has larger gravitational strength, is it possible to use the gravitational strength to generate energy, sir? Sir, or else it will go against the law of conservation of energy, sir.
Now, how it will generate energy? The hole will do is a conduit only. Wormhole is a conduit. So conduit is connecting black hole and white hole. But so how it has got gravity, I understand. But it is not having any force to do that. It is only absorbing what is available in the singularity. It draws that and pushes it to the white hole. What is
Sir, but sir, no, sir. I'm asking that if drops into a weaker side of the gravity, it gains speed and near to the black hole, no, sir. So with the help of that, we can form energy, no, sir.
How do you generate? No, energy means what? It is pulling. What it does is it's pulling. That is the energy it uses to pull the stars which have been absorbed and then pull it to the and throw it to the white hole. That's what it does. So there is energy in that. But you cannot generate energy out of that.
Oh, okay, sir. Thank you, sir.
But still, it is not understood yet. What you are asking is a good question, but the whole thing is not yet proved yet.
Sir, and also I have another doubt, sir.
No.
Sir, you said that you can calculate mass of the star by using this telescope, no, sir. Why can't we use the kinetic energy formula, sir? For example, we can take the kinetic energy of the particle of the star, and then we can find the velocity, and then after that we can find the mass, no, sir.
Good. Yes. See, kinetic energy is half mv squared. M is there. Okay. So velocity, this is what I also told you. Velocity is the speed, right? When there is a speed, the speed is seen by the telescope. So speed is what? Time and the distance. So distance divided by time is the speed. So once you know the speed, you can calculate the mass depending on the energy which is generating. So energy measurement is occurred. So kinetic energy, if you can measure, you can find out the mass.
Okay, sir. Thank you, sir.
That is possible. What you are saying is estimate you can make.
Okay, sir. Thank you, sir.
Thank you.
Sir, I am Prasanna Venkatesh. I'm studying 11th standard from Sara Metric High Secondary School, Tirthirepundi, sir.
Prasanna, yes.
Sir, my name is Prasanna Venkatesh. I'm studying 11th standard from Sara Metric High Secondary School, sir.
Question.
Sir, is universe be made of entirely of antimatter?
What is it?
Is universe be made entirely of antimatter?
Antimatter? No. It's matter. Antimatter is a different theory. Matter and antimatter. We will discuss that later. Antimatter, matter. No. Because we are going to talk about antimatter propulsion. So many things we are going to talk about it. But you see everything. If you take Earth, Earth is what? What do you say, matter or antimatter? Earth.
Earth is a matter, sir.
Matter. So many planets are there. They are matter. That's what I said. 0.03% is the matter. That's what I told.
Yes, sir.
The remaining
Yes, sir.
is gas. Remaining is gas. So
Yes, sir.
matter and gas is there. That's
Yes, sir.
universe. That is the universe.
Is possible to Big Bang happens again and create the new galaxies and the universe?
New galaxy formation, if the new stars generate, they are all generated within the galaxy only.
Okay,
no, so far new galaxies have not come, but it is possible. It is possible if the new stars come out of the galaxies, then they can form a new galaxy. If it is coming.
Sir, I am asking him. I asking to is possible.
Possible?
Is possible to Big Bang happen again?
Big Bang. If the universe dies, then next Big Bang will come, is what people say.
Okay, sir.
Big Bang cannot come again and again.
Okay, sir.
First we will all be vanishing. Then only next Big Bang will come.
Oh, okay, sir.
Sir, good evening, sir.
Good evening.
Shutilaya Srikanth of Wales Global School, Mogapur, sir. Sir, you told life is possible on tilted planets, sir, but it is not possible on...
Hello, slow. Is it possible?
Is it possible on Uranus, sir?
Possible to go to Uranus?
No, sir. Is life possible on Uranus?
No. Gaseous. It's gaseous. It is not in the life path.
Good evening, sir. My name is Hari Kishore from Sara Matriculation Higher Secondary School, sir. Sir, how will be the Milky Way mass is calculated, sir?
Milky Way consists of, so many stars,
Yes, sir.
Any galaxy has got stars.
Yes, sir.
So the telescopes see different stars. So there's a computation on the stars. Then
Okay.
each star weight is mass is calculated.
Okay.
Then they go on computing because the whole galaxy is moving. From there, they find out the energy generated and also the speed. They find out. From that, they recalculate the mass. That kinetic energy principle, what one student was telling, that's also possible.
Yes,
Or
sir.
you calculate based on the energy generated from each one, each star you calculate, then go on computing. It's a very big calculation.
Okay, sir. Thank you, sir.
Okay, thank you.
Good evening, sir. Good evening, sir. I'm P. Rajagopalan from Javaga Higher Secondary School, sir. The question is, Earth got its natural satellites by Theia planet when the Earth is struck, sir.
Not clear what you are asking. Your voice is cutting. Next question. I think Dr. Balmurugan.
Yes, sir. Yes, sir.
I think we should control the time.
Yes, sir. We can close it with one question, sir.
Yeah.
This last question alone,
We
sir.
will see.
Have.
We can
Yes,
have
sir.
the
Good
questions.
evening, sir.
Yes. Dhanalakshmi.
Yes, sir. I'm Vishri Dhanalakshmi from E-Road 9th Standard, URC Palaniammal Matriculation Higher Secondary School.
Very
You
good.
have mentioned that universe is made up of dark energy and dark matter and other elements, sir. What is the difference between dark energy and dark matter, sir?
See, I was telling you, the whole universe is dark. Okay.
Yes, sir.
Then the dark is 95% of the universe is dark. Nothing is there.
Yes, sir.
And we are seeing the movement of the galaxies.
Okay, sir.
So galaxies are moved by a force. What is that force? It is a dark force. That is what we call it, dark energy.
Yes, sir.
Then all the stars are going together when the whole galaxy is moving. All stars are going with that galaxy. That how it is the binding happens. It is because of the dark matter.
Okay.
This is the difference between dark energy and dark matter. Okay, thank you.
Sir.
Thank you very much.
Yes, sir.
Thank you,
so
sir.
much. Thank you so much, sir, for your timing. So, sir would be having more classes in the forthcoming days. Students, we know your eagerness and enthusiasm. So, we can ask your question at the later classes. Thank you so much for your time. Thank you so much, all the coordinators, sir. Sir, thank you, sir.
Okay, thank you. Thank you, students.
Thank you, sir. You can close this session, sir. I'll close it, sir.
Okay.
Bala sir, okay, we can inform. Okay, students, I think next session will be there in the Saturday. So we will announce in our WhatsApp group and be ready for the second session. Maybe for the students who have been left, maybe your friends are there, please indicate them. And any of, I think today attendance will be taken up and that will be circulated in your mail also. So from today onwards, the attendance and your interactions and the questions like which you're going to ask at the quiz competition, which you're going to ask in the end of the final session. So will all be calculated for your next level of. So once again, I thank our coordinators and the students, the faculties, as well as our Rajalakshmi Madam and Kapilan.
Gokul sir, your voice is not. We are
making
not.
This first day session a wonderful.
Okay then. Thank you so much, Gokul sir. Actually, students, we know the eagerness and other things. So don't be in a haste to put up such questions. So your questions should be answered at a later time. So make a note of each and everything, and your questions should be related to the session alone, not with your intelligence. Your intelligence might be even vaster than Pillai sir, but our request is that you follow the lesson plan, and then and there you note down the questions. Whenever there is a query related to that particular class, you can raise up your questions there. Not that you ask your questions with your intelligence. Yes, then I could understand it. Jaitaj, what do you want? So is there anything to convey?
Sir, na student side placement answer.
என்னதுமா?
Student side placement answer.
புரியல.
No, you want to talk to Pillai sir. Okay, you can
Yes,
ask
sir.
to next time. You can, that's what I always say.
Okay, sir.
First come, first serve. நீங்க
Okay,
first day
sir.
வந்து ரைஸ் பண்ணி நீங்க வந்தீங்கன்னா questions கேட்கலாம்.
Okay, sir.
Question answer session today it has taken almost 1 hour 10 minutes. So that is a long session. But next time people who are coming first, they'll be asked to ask the question.
Thank you.
So next, okay, as we said, next session will be on Saturday. We'll update in our WhatsApp group. So request all to make your presence as early as possible, 5:30 to 6 o'clock. Okay.
Okay, ma. Thank you. So all the students should rename when they join. So today it's the first session. So அதுக்காக நீங்க அதை பத்தி கவலைப்பட தேவையில்ல. நெக்ஸ்ட் செஷனுக்கு நீங்க எல்லாத்தையும் மாத்திக்கணும். பேர் இந்த டிசிப்ளின் இன்னைக்கே சூப்பரா இருந்துச்சு. ஃபர்ஸ்ட் டே மாதிரியே தெரியல. ஸோ போக போக இது பண்ணீங்கன்னா கூட சேர்த்துட்டு உங்க ஸ்கூல்ல இருக்கக்கூடிய ஸ்டூடெண்ட்ஸ் யார் யாரெல்லாம் வரலன்றதையும் பார்த்துட்டு அவங்களையும் கனெக்ட் பண்ண சொல்லுங்க. ஸோ கோஆர்டினேட்டர்ஸ் ப்ளீஸ் ஃபாலோ இட். Attendance is very must for the next stages too. So but today it's going to be the first session. We would be taking up the attendance, but still we request people to join immediately. So whoever is left out with the cellular connectivity or battery connectivity, whatever it may be, so ensure that you are connected with the session. Thank you so much, ma'am. Thank you. We are closing up. Thank you. கபிலன் என் பண்ணிடலாமா?
ஓகே சார் பண்ணிடலாம்.
தேங்க்யூ மா.